So based on yesterday's fourth
Yes.
case, let's make a summary.
Okay.
We did is the diagnosis of electronic control system, or the fault setting of electronic control system, electronic fault. No mechanism for fault. So when we diagnosis of the electronic control system, first we should know the function, how to use it. Okay. For example, yesterday we should know how to start the car. Okay, how to use it. The system, the function, how to use it. And the second is consists of the system. Consists of the system. For example, this is a simple electric system, control system, and we should know the system of sensor and controller and actuator. Three parts. Sensor. So this is a simple system, so it's no sensor. But the controller is here, the switch, yeah. And the actuator is here, the lamp, yeah.
Sensor is what?
Sensor, this has no sensor. For example, the current sensor or the voltage sensor, yeah. But here is no sensor. Not every system has sensor.
Okay.
And the EV car, the EV vehicle sensor is less than gasoline car.
Oh, really?
Yeah, because EV vehicle sensor is a current sensor, and as a I don't know how to say in I translate for you. Rotary sensor. The position of the motor rotary.
Yes, the rotary sensor.
The position is a position sensor. So the EV car has less sensor. But
I realized. Okay, I understand.
Okay.
It has less components, obviously.
Computer.
Components. I mean, it has less. It has less items. It has less things. The ICU has more things, more components.
Yeah.
Than the EVs.
Yeah, more assemble.
Yes, more assemblies than EVs.
Yes.
And then the EVs also is managed. Is managed by the HVIL.
HVIL.
Yes.
HVIL.
So there will be less sunsets because that one already monitors anything that wants to go in and come out.
Yeah. In EV cars, we repair it also. For example, if this have problem, if this fault, we just change it. We just change it. And the sensor, most the sensor, in, most of the sensor in Japanese. So we outside of this sensor is less. So when we fix, we just change it. But if we know much, we can omit and found the
Particular fault.
yeah inside
Trace it.
yeah, and we change it.
That also means that in terms of maintenance, we should change the equipment first.
Yeah.
Then, when this car has been fixed and the customer has gone, we can now open the system to begin to diagnose.
Yeah.
Maybe we're able to fix, we leave it for another car to come.
Yeah. So we can do more.
Yes.
More.
Yes.
Yeah. Okay.
Okay.
So the second is know the consistency of the system.
Yes.
For example, battery, lamp, switch, and this valve to consist of it. And the third is principle. Principle of the system. The work priority. You know, for example, here, first switch close, and then the power through the switch to the lamp. Work priority level. And also found the loop.
Okay.
Because not every system in the diagram has its own loop in the diagram. We should to connect one part and set two parts and connect together. The system maybe for example, is a diagram. The system here has the system, and here has the system. Here has the system. We should connect it to
Into
a loop, into a single loop.
Single loop,
Yes. Okay. So this is important. And the fourth is to know the installation position. Installation position. For example, we can find the loop, and we know how the lamp work. But when we want to find the problem of the lamp, we should first know where is the lamp
located.
Where is the lamp? Yeah. Installation position. And five is if I have problem, we should first check the fault phenomenon. Check the fault phenomenon. Like yesterday, see the light, see instrument.
Yes.
Instrument. In the car, instrument. Okay, we should see the instrument first and see the car function. The function is okay.
Oh, I mean, you mean the dashboard?
Yeah,
The display screen.
Yeah. Screen.
Yeah, the screen. Yes.
The screen. Yeah. Okay. And when we know the fault phenomenon, and we can analysis. analysis. For example, the yesterday's problem. We also use this to analyze yesterday's problem. Because the screen can light on, we can first identify no battery is okay. No battery is okay.
Okay.
If no battery is
The screen will be blank.
yes.
Okay.
And we can also we use this. This diagram. We know, as we know, the battery is from the power from the battery and from distribution box. And through the fuse, from distribution box and through the fuse to the instrument distribution box in the car, the box in the car. We say the PCM connect with the PCM. And here to the fuse, and this fuse is give power to the screen. Okay. So the screen light on.
Yes.
Means this way is okay.
Okay.
This way is okay. Okay. And the phenomenon yesterday, okay lights on. So HV out. HV is output. So you know HV output means every means the module of low voltage is okay, because when yesterday when take the fuse off, the fuse charge of the OBC and
The OK did not come on.
yes, if the OK is light on, so means the module is okay. Module of low voltage is okay. If
So these are two things.
yes，名额在隔壁上头。
So these are two things. Number one,
Uh-huh.
that OK light
Mhm.
means that the HV is okay, might be okay, right? Because that's
HV is
what
okay.
HV is coming and it brings output.
Yes.
But to the low voltage module is okay.
Yeah.
So that a test confirmation, that OK sign is a test confirmation.
OK sign is
Test confirmation that this system is working.
yes.
Okay, so that's nice.
Yeah. OK means the car can drive. Or some cars is ready. Some car is ready. OK already means car can drive. And if the car can drive, most of the module is okay. It is no problem. So
All cars must have that confirmation sign, either OK or ready.
yeah,
It's all EVs.
all EVs have this light.
Excuse me.
Teacher Yang. Afternoon.
I will visit the factory this afternoon. Okay. Let's see.
So my brother is here also. Two of us are coming.
还有个朋友在学，我在休息课。
Okay.
Like you see in the afternoon.
Yeah. I'll go there directly and we'll see you there.
Yes.
Okay.
Thank you. Thank you.
好，对。
不
我知道昨天文静讲，要不要再交流一个？好的。
你讲的那个学问课好。
贾老师。
还就。那你像我们现在我回去会说你在北京的。好，不要再聊了。完了，那还有我是连笔画带猜的。
This one I don't understand.
You have seen?
Yeah, so she'll be taking us in the afternoon.
Oh, okay. Afternoon, she take you to
To the factory, yes.
Yeah. She's also the teacher for Li Auto.
Oh, really?
We in Li Auto program in our school, we have 4 teacher, 2 teacher for the technology, 2 teacher for the after sales service, for the I would say SA sales.
After sales, that's maintenance.
Yeah. We say it's technology or service.
Okay, yes,
Two
services.
way
Services.
service. Yeah. Okay. We come.
Yeah, okay. So, we're still talking about the OK and ready sign.
Mm-hmm.
So it is the HV output.
Mm.
The LV module is okay.
Yeah.
The low voltages.
Low voltage model is okay. It's okay. Mostly the okay lights on or the ready lights on the old model is okay.
There was a thought you said. I didn't know. You said about 3 things. I didn't pick it.
What things you don't pick?
On that sign.
No. This sign.
Still talking about the OK sign.
Okay sign.
You know, the thought you said was associated with it. I didn't pick it. I didn't write it down.
Okay.
I know about the HV output is okay, the LV module is okay. I'll get it. I didn't write it. You mentioned it. About the OK sign, that means okay, fine. The power has gotten to
the motor control unit.
Yes.
The power is output. OK means the power is output.
Yes.
The high voltage output. And you know, in the EV cars, the HV output is the final step. If the car has any problem, the HV power is not output. So the HV output means the car is ready. The car has no problem.
Oh,
most of it.
Thank you. It means the car can drive.
Yeah.
That's what it
The HV power output is the final step. The module will check every system first, and when it's okay, the high voltage will output. And in the detail, yesterday, this DC problem appeared is a few moments later. You remember? Because this DC is working off H3 output. So when H3 output, this is not working, and the vehicle can uh, can 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 realize that the car has a problem because this is working after the H3 output. So any anything working before the H3 output, when the OK is light here, when the OK appear, uh, everything before the H3 output is OK.
So, um, the DC is after the HV.
Yeah, after.
After.
The H3 output to the DC and DC translate.
Yes, yes,
DC.
because the DC is taking power from the HV.
Yes.
Okay.
Okay.
So that's why it was able to peak. It showed the OK sign, but gradually the battery was reducing.
Yeah.
That would have later created another error sign because the battery is going to drop a little bit more. It wasn't charging.
Yeah.
But like you said, if it is less than 13 volts, it means that DC is not connected.
Not connected.
Or it's not working.
Not working.
So, but if it is more than 13 volts, it means it's working.
Yes, because above the 30 watts. Yeah, because many module. For example, VCU have a valve from the battery.
Yes.
To give the VCU power, and the VCU also can check the watt of the.
Yes.
Check the watt.
Yes. The vehicle control unit.
Yeah. If the H3 output, the watt should above
above 13 volts.
Yeah. If he is less than the 30 volt, the VCU will. So yesterday, the low battery has a problem. Low battery has problem. Yes. So he can check it. He can check it.
All right.
Okay. So it's the analysis of the phenomenon. We can analysis based on the phenomenon. We can do analysis. And then is the test. Where we do after analysis, we can test the. For example, yesterday we can test the low battery watt and test the connector between the DC to low battery. And the test we usually use test the watch and the resistor. In the vehicle pickup, we also use this. And a waveform, waveform. For example, this a waveform. Use scolio. Use this, scoloscope, or he can test the waveform of the vehicle and
That's basically this.
Yes. his is the frequency, change the frequency, and this to
The
change.
waveform.
Yes. Okay. We all use this today.
Yeah.
The frequency. Okay. This is then we test, and about the test we do the test results. We do test the result analysis. For example, is also here. Uh, for example, if the test here, if the switch is closed, and we test the voltage, here is 0. Here is 0. We can first the test result is have problem.
Because the switch is closed.
Yeah, because the switch is closed. And for example, this is while this have a box. Sorry. This is while if we test the point A have a 12 volts, and the point B is 0 volts.
The wire is having problem.
Yeah, the wire is okay. So this is through the test results we can analysis what the problem. So this is the step we do diagnosis of electronic control system. And the last step is to repair. When we found the problem, we repair it. So the consists of the system and the principle and the installation position can all found in the diagram. So the diagram is very important. Okay. And
That's a low voltage diagram. Once you show the Is it a low voltage diagram?
low voltage.
No. Which of the diagram?
Which?
The diagram itself is very important. Which of it?
Which of it?
Which diagram? Let me see the diagram.
Okay. Yesterday I sent you a diagram.
Yes.
We can we just see here. We can the diagram we can consist of the diagram we look. And first, it will tell you the valve, the color of valve. B, L, B, R, G, G, R, L, G. You know the color of it. And this yesterday I said the F mean fuse, and the number after the F 1, 2, mean the position of the fuse. And K
K
means
is for
relay.
relays, yeah.
K means relay. And we next. So these two is the two distribution box, the front and the in the car. The two is distribution box, the fuse, the number of fuse, and the function of fuse, and the function of relay. Is page 3 to page 6. And then here, page 10 to page 96 is the valve, or the valve. And the valve and the plug on the valve. And we can show you. For example, this valve have many plugs on it, and this valve is from left front door valve, and this valve has many plugs. The number of the plug T06, T07, and then it will show you, for example, T06 was the what?
The inverter.
Yeah, the 外观这个外观
appearance.
appearance of the appearance of the plug.
Okay.
And the spin number and the spin position.
Oh, okay.
Uh,
I get it.
Got it? Okay. And here is the plug description or plug's name. So if we can use this to find the opponent. For example, we want to find this valve from the ACC relay, and this valve is in the G2E plug, and the 17 speed. So we want to find the valve and test the valve, the voltage of the valve. So we can first find the plug G2E. We found it. Here is the appearance of G2E, and the 17 speed is here. Is here, and we can use the diagram to find the speed, find the valve, and the G2E, the position is the G2E. G2E is here. It's here. Connected with the BCM here. This is the driver position. this is the passenger position. Is right here. You can use this to find the plug and find the valve. Okay. Okay. So the diagram have all the plug, all the valve in the diagram. You can use this to find the valve. And after this, after the plug is the diagram, the system, the diagram of the system, diagram, and we will to one system will to use the diagram. Okay, have a problem. Yeah.
Trying to. So basically, this is more like for diagnosis.
In Nigeria, you repair the car with the diagram, use the diagram.
It depends on the car. If it's a new one, yes.
New one.
But if it's second hand,
Uh,
the diagram might not come with it.
oh.
So you can go online
Uh,
to get documents. Sometimes if it's a German car is written in Dutch,
mm,
you know, we have to translate. But what we do, we look at what is similar to what we have.
mm,
Then we can use that. We also have the OBD testing equipment. So we use that one, the translated version, to check. Because sometimes diagram might not be available. It's a brand new car, diagram is there. You just go straight to diagram, open the book, and then
yes.
get what.
Yes.
But if it's not a brand new car, if it's second hand, you might not have all those information.
Not have the
Yes.
diagram.
Especially if it's from Europe. All those European language like Dutch, Spanish. If we cannot see what is there and then we cannot download on the internet, we'll go to the nearest service center.
Go to the
Service center, after service center. We can always get like some in Lagos or other parts of the country. Yes.
Yeah.
So it's the way we manage to use that. But for brand new cars, no issues. Diagrams.
Okay.
We always document to use.
Okay. So the diagram can tell us the position of the devices and the loop of the system. For example, this diagram is two relay, and the power is from here. This is battery. Yeah, the battery and to the big fuse, 80 amps. To the 80 amps fuse we received yesterday, and here to the instrument distribution.
往我去放在桌上拿东西，那个刚刚过去的是放在一个请假条在我桌上面，帮我去拿下，就是我放在桌上面，放在桌上面，我拿过来。
in the distribution box. And
On that steering, the second one, or this one.
the second one in the car. Yeah, the battery to the front one, and to the second one, and to the ACC relay, and to the devices, give power to the devices. And the relay will control by the DCM. The relay will control by the DCM. This principle is if the VSM have 0 volts. The coil will have electric because here is a 12 volts, and here is like this. Like this. This point is here. Is that control this? Is that give a 5 volts? The this can connect. This can connect, and it will connect with the ground.
That's the body of the car, the chassis.
Yeah, chassis. If this switch closed and then connected with the chassis, and then the coil will have electricity, have power, and the switch closed. And if the BCM cut it off, here will be this point, the watt of this point is 12 watt from here. So if you test it here, it's a 12 watt. This will be open. 0 watt. This will be closed. 12 watt. 12 watt. This will be open.
So every time there is current, power from the low voltage battery, the relay opens.
Power from the low low from the battery and to the relay.
So,
Yeah.
but once power enters, the relay opens. I don't get that. So this is 12 volts coming. That's the relay.
No, this is not relay. So okay. Principle is this. Can you understand this? And here is the BSM, how to BSM control the relay. This I translate. Use if the BSM here is a module, is a CPU. If this give a 5 volts voltage, this device will connect
So 12 volts.
or 12 volts. Yeah. It's a control. It's a control. Give a volt, it will connect. If here is no volt, it's 0 volt, it will disconnect. Okay, so the BSM can control the device and to control the coil heavy electricity or not heavy electricity. This is like a switch. This is like a switch. No. This is like a switch, and the switch controlled by the BCM. The BCM closes, and the coil have electricity, and the relay closed. And if the switch open, if the switch open, this coil have no electricity, and this relay is open. Okay. We set control this and control the relay. This is the relay control system. Yeah, relay control system.
So the presence of current is open when the voltage is 0, it closes.
Yes. So if we test, here is in here in the diagram is G2E17. If we test the speed, and here is 0 volts, means the relay, means the BSET have control the relay to collect, to close. And here, if the volts of here is 12 volts, the voltage of here is 12 volts, means this switch is not closed. It's open, and this relay is open. It's open. Okay.
Let me make it look.
So about the diagram, any problem in this?
You sent it to me, right?
Yes, they will understand to you. But all of this is Chinese.
I can translate it.
Okay.
Understand it
So
better.
the diagram we should to check the problem with the diagram. When you check the problem, you will know the diagram more. So no worry. It's a big system. It's a long time to know it. Have a rest.
Don't worry.
Let me take 30 minutes.
Get some coffee. Get some coffee.
Ah.
But like, you don't know, I don't see the videos of. Are you losing? Are you losing?
Get some coffee.
You wasn't losing off. Right? Was it losing?
Yes. It's a clean engine. Fresh air.
Even me, I'm following what you're doing. It's pretty interesting.
The process, will be difficult. Will be a little bit difficult.
Okay, I think as we were doing it, I was trying to get some because I think I was like there are some things that I know, like I understand from these basic things that I researched myself online. So when you were explaining, I was able to connect those things to what you were showing.
今天是讲什么？
讲电路，讲诊断的一个流程。
Baba G.
Let me clear my head.
这个压不下去了，
对这个。
压这点就弹上来了。
休息一下，休息一下。杨金老师刚刚也来了。
对，来了，
刚才认识了。
认识了。
我们下午就要去
对。
那个陈总也下午回去了。
他也去。
我直接在北京路上。
那行。
到了。
讲诊断的可能是有一点
难。
对。
没事，那么难。让脑子烧一烧，休息。就是后面马来西亚的学生来诊断的少
不讲这些，
对，
就搞一些附件的认知，搞一下功能的使用，实验功能的使用。
是的。
差不多了。讲诊断呢，他们更加难搞。
是的。
然后把电池包拆了给他们看一看。
对，多搞些认知的活。原理认知。
So this diagram, they are also on that diagnostic part.
Yeah.
Okay.
Yes. It's so the diagram is